Hello guys, so in this video I will be talking about how you can do machine learning in PySpark. So we will use the dataset which is named by home credit default risk. This dataset you can get it from Kaggle website. You can download it, and also you can create a notebook in Kaggle and perform the PySpark. Uh, PySpark thing here in the Kaggle itself. So you can also create your own notebook here. So what you need to do is you need to see firstly the data description before you move ahead. If the better is to read about the data set, because this data set is having more than 5 to 6 files in it. And the problem statement of this problem is that if the certain person has given an application for a loan, and we want to predict whether that person will be able to repay the loan or not. So the institution name who is giving the loan is the Home Credit, and Home Credit wants to know that if we can predict whether an applicant is able to repay a loan or not. Obviously, the applicant, we would like to know his previous history of the loans he has taken, whether he has taken from the home credit or he might have taken from the other institutions apart from home credit itself. So these informations are available in different files here, and also the installments of the previous loans he might have given if he has taken any loan. If the person has not taken any previous loan, then there will be null values for that person. But if a certain person has taken previous loans from the home credit or from some other institutions, there will be some rows pertaining to specific person. Now we have application data, which is application.csv. One is for train data and one is for test data. This is the main file, and it has the information of a particular applicant ID we have there, and we want to predict the target, which is 0 or 1, whether the applicant will be able to repay the loan or not. Then we have bureau.csv. This is for other financial institutions apart from the home credit. And we have other informations of the client, previous history of the client regarding the loans. Then we have bureau underscore balance. It also gives the balances of previous credits. Same way you can read about post cash balance and credit card balance. Previous application file is specific to home credit. So any previous applications to the home credit any client has made, we will be having those rows in this data. Installments, again, this is specific to home credit. So what is the repayment history of the applicant specific to home credit? So we won't be using, because our purpose is not to study the machine learning, but we just want to see what is the structure and how do how we can perform machine learning in PySpark using given these data sets. So the objective is not to go into the specifics of machine learning here. So as we will not be optimizing for AUC or other metrics of precision or recall, but we will be just seeing that how what is the flow, what is the pipeline to start from the data set, and how to achieve the predictions for the test data set and get AUC or recall or precision. So we won't be using all the data sets, as we are not optimizing for all those things, but some data sets which we will be using it will be installments, previous application, bureau, and application. Application is the main data. So let us begin and let us see. So here we need to first install the PySpark. So we will first install PySpark. This is a notebook which you can create in Kaggle, and let us install first PySpark. We will install Java as well, JDK, and we will also install this PyDrive. It is used for Google Drive. Though we don't need it right now, but if you doing all these things in Google Colab, then there you would be requiring this thing. So let us run this code also. Okay, while it is running, let me walk you through the code. And so these are installing PySpark, this thing, and then JDK. And we will also install the Ngrok, and this is Ngrok. So basically Python Ngrok, you can say. You can install this also. After installing, you can import the Spark context and Spark configuration and session, and also import the Ngrok. And the purpose of Ngrok is to see the PySpark jobs, stages, and tasks. So this is how it will look like. When you click on the link, I will show you how to reach to this link. You can see the stages and the SQL data frame jobs and all these things here. uh, you will run this thing. Once you have done this, you can run this. Okay, you need to install this thing. Okay, this is installed. Now you can import these ngrok and the Spark session context and configuration. You can define the Spark configuration as this, and the port for Spark UI is 4050. You can set a certain name for this Spark application, and you can just create the Spark context from this configuration, and also build a Spark session. So let us run this line piece of code, and now we can see that Spark is up and running. So if you get no error here, definitely it means that your Spark is now running. And just to reach to the Spark UI, I will tell you how to reach. You have to do this piece of code, ngrok auth token, and wherever you see the star, you have to actually sign in for ngrok, and get your authentication code and paste it here where you have to asterisk, and just run this piece of code. After running this, you will run this piece of code and this piece of code. After this, you will get this public URL. Once you click on this link, you'll reach to this where you can see all the jobs, stages, and everything here. So the purpose of, you can see how much time it is taking, which job or task is stuck. You can see everything there in the PySpark UI. Now you can change the directory to home credit default risk, and this is in Kaggle. After this, we are going to read the data. So the names are underscore bureau underscore previous app underscore installments. Just take the Spark and dot read dot options, and for schema is true because we want to read everything as such, whether it is integer, double, or whatever the type or data type is. And You can define the delimiter, and we are going to read the application frame file, bureau, previous application, and installment files. After this, what we will do is so basically you have two IDs. One is the current ID, which is SK underscore ID underscore current, and we have some columns which is days credit end date, days end date fact. We will take these. We are not going to do the analysis here, but we will see that how we are going to use some columns in the data and how we will process them and create the final data and perform the machine learning there. We will change these bureau column names to max because we will do some aggregations in this data set. What we are doing here is we are changing the column names from max and we have brackets, days credit. We will convert into this these column names bureau underscore max underscore like that. We will see in a moment. So we take the df underscore bureau data set, we select the key column, which is current ID. We select the bureau calls, these columns, bureau calls, and group by the key, which is the current ID of the applicant, and calculate the maximum for each of these columns, all these three columns. After calculating the maximum for all these columns, we are renaming them by using this false dict dictionary. So we are iterating over this dictionary. We get the key and value, and these key values are basically nothing but these values in the dictionary. So this is after the aggregation, and we want to change this name to this one, which will be bureau calls max uh, first uh, first element of this list. So we have three elements in this. So first will be bureau max days credit, bureau max days credit end date, and bureau max days end date fact. So once you run this code, what you're doing is we are creating one one data frame here from df underscore bureau. You are renaming the columns, and after that you are just joining by the main application file. So we are doing left join because the main application file is on the left. So we will be doing a left join on the bureau data set here. Now, just to see how this data will look like after the join, we will select the key columns and the bureau calls max, and we will filter with some IDs. So these are two IDs which we are filtering. So bureau the data frame dot select these columns dot where this ID is in these two values. So we get these two IDs 281 These are the IDs of the applicant, and these are the aggregated values, maximum values of the columns. These columns bureau calls. So we have renamed them. So basically, we are doing nothing. We are just taking these columns, grouping by, and calculating the maximum, and then renaming them, and then joining back to the application data set. Similarly, we will do the similar kind of thing in installments data also. So selecting the installment data, taking these two column previous ID and amount payment, and calculating the minimum after grouping by previous ID. So for each previous ID, we are calculating the minimum of amount payment which has been done by the client in the installments data. Now we got the df underscore previous app dot join. So we have the df underscore previous application file, which is which we have read here, df underscore previous app. This file we will be joining with the this installment file after the group by, and we are joining on the previous key and renaming the column name to amount underscore payment. So first we are calculating the minimum, and then we are renaming it to amount underscore payment. Once we have done, we can see how this data looks like, df underscore previous app. So basically we have joined it with the installment file. Df underscore previous app is joined with the installment files. Once you select this and filter by the current id, you will get this something like this. Now third is again we are using the current id, and we have these column names which we will be renaming after the aggregation. So we take the df underscore previous app, which comes from the previous processing, and then we are selecting these columns, key and the payment calls is this amount payment, and we are grouping by the key, which is the current id, and then aggregating for the amount payment. We are calculating the sum and the average of these. Then again we are just renaming these columns for the sum and the mean by these names. So we are doing it here. We after this thing, after the join, we will be doing a join with the main data frame tf. So this is the complete flow which we have done. So first, in the first one, what we did is we took the bureau data, group by, calculate the maximum, and joined by df. In the second one, we took the installment files, grouped by the previous key, calculated the minimum, and joined by the previous application file and renaming them. And in the third, we are again doing some aggregation on the previous application file by the current key, and calculating the minimum, calculating the sum and the average for the amount is for payment. And then again we are renaming and just running with the main df data frame. This is to get the final data set. So you can see here how it looks like. Now we have the base calls which are present, and we have bureau calls max and previous aggregated calls. These columns, we will take only these columns. We have number of columns in the data sets. We have multiple files. You can use all of them, but the purpose is not to optimize here. The purpose is just to see how we will do the PySpark ML code. So we will import all these ML PySpark.ml classification, random forest classifier. You can import gradient boosting also, the GBM classifier as well, and then for param grade builders for parameters defining, hyperparameters defining, and cross validator for cross validation, binary classification evaluator for evaluating the metrics, and so definitely you will just import all these things. And vector assembler, I will go in a while, and pipeline is for combining the complete flow, but we will not be using the pipeline here. We will only use the vector assembler here right now. So we are going to select the features, all the features plus target, and we are filling the null values by -1000. We should be doing it by more better approaches, imputation after doing some kind of data analysis. But I'm just using it -1000 just for the sake of purpose to see how this thing is being done. We are just renaming the target column by label. Then here what we are doing is in vector assembler you give the features, all the features as the input, and you create a column which is a vector, and that vector has all the columns in it, and this will be features. So features will have all the columns included in it. So this is vector assembler. You just transform the data set, which is df underscore t, which is this one. You get the training data set. Here you are just importing the GBT classifier. Your label call is label, and the features call is features. This is the input data, and this is the output which we want to predict. We are not using random forest classifier. We are just using GBT classifier here. You define the param grid by using param grid builder. You can define other parameters as well. Here I'm just defining the max depth and not for this SC. Uh, Here now, after this, you define the binary classification evaluator, and you define the cross validator. Inside this estimator is the GBT, which you have defined here as a classifier. You are defining the parameters here in the estimator param maps, evaluator in the evaluator, which is evaluator underscore M, and you can define the number of votes for the cross validation. So I'm just taking as two. You should take 4 or 5 for better, but just I'm just to see how this thing is going to work. And now you I'm not going to use the actual testing data set. I'm just splitting the training data set into two parts. One is training data and one is test data, split by zero point 0.7 and zero point 0.3. So 30% comes in this test data and 70% is this training data. You just split this cross validator into the training data, and you get the predictions by transforming the test data by using the CV model dot transform. This is you will get the predictions, and predictions will be like this. You can select label, prediction, probability. So this predictions is basically a data frame which has many columns in it. One is label, one is prediction, one is I'm selecting only these things. Label is actually the actual labels, prediction is which is being predicted by after the cross validations. And now here you are calculating, evaluating the your AUC by the predictions. You just give the predictions here and evaluate it. Area under curve, you will get some value here. Similarly, you can do for area under PR. This is a simple workflow to get to predictions and calculate the important thing is what you need to do is vector assembler is important. You need to give the features in it and create output. This is one thing which is assembler. You need to transform your training data set, and you need to define the model, which is GBT classifier or random forest classifier or in logistic regression. You can define anything. You just need to define your label call, and you need to define the features. Then you need to define the parameters using this one, parameter to builder. You need to define the binary classification evaluator, and then ultimately you need to define the class validator. You can also get the best model from CV model dot best model, and you can find the parameters of the best model as well, which and one more thing in the parameters, here you can give a list. So I'm giving max depth as only 5. You should have given maybe list of 4 or 5 elements just to optimize and see for which combinations of the hyperparameters your cross validations metrics are best. And so this is all. So basically, if you wanted to do the prediction on the actual test data, you can again do it by just transform the actual test data, get the predictions, and so for this one, I have calculated for the validation data set, AUC, and the area under PR curve as well. So this is all. If you have any questions, you can ask me. And this is if you want this notebook, I can give you. And you can ask me. I can post it in GitHub or somewhere. So thanks for watching this video.